Today we're going to talk about solving quadratics using the quadratic formula. So the quadratic formula gives us solutions to any of our quadratics as long as they are in standard form. Now remember, what is standard form? Standard form is that ax squared plus bx plus c, and that's the form that we have to have our quadratics in to be able to use the quadratic formula. So let's talk about this quadratic formula. So here we have the quadratic formula equation. Looking at this thing, it looks crazy. There's an awful lot going on in here, but what I want you to notice is that once we have this standard form, we have the a in front of the x squared, the b is in front of the x, and then the c, remember, is always the constant that sits by itself. So once you're in that form, that's where we can plug into these numbers that you see in here for the variables a, b, and c. Also notice that this is going to be what x equals. So remember, as we're solving this, x is going to end up being our solutions, which are also our x-intercepts if we were graphing this, or we also call them our roots. So this equation is a crazy formula. It's a crazy equation. It's very important that we are completely following our order of operations as we go through this entire thing, and that we allow plenty of room and space to get through our work so that we don't make one silly little mistake and then throw off our answers. A couple of things mathematically you want to notice: that a cannot be a 0. If a was a 0, let's think about that. If a was a 0 up here, there wouldn't be an x squared. You would have bx plus c equals something, and you can just solve it, right? But also, a down here, 2 times 0 is 0, and remember, dividing by 0 is undefined, so I can't have a as a 0. The other thing you'll notice is this b squared minus 4ac. This is this phrase or expression right underneath the radical, has to be greater than or equal to 0. We'll talk about that a little bit further on. If you think about it, if this underneath stuff becomes negative, we can't take the square root of a negative, and that would stop us also kind of dead in our tracks. So let's just kind of do a couple of these to see how it works. So when we have this first example, we have the 2x squared minus 5x plus 3. We want to use the quadratic formula to solve this. So we're not factoring, which we could potentially try to do. We're not trying to graph this. We're not trying to complete the square. This is another way to do this, okay? So remember, the a is this number right in front of the x squared. The b is the number in front of the x, and c is the constant by itself. So first, we're just going to plug in what we have and then solve from there. So notice that it is a minus b in the top, which means it is a minus negative 5. It's not just negative 5. It's got to be a negative b, so it has to go in as a negative 5 also. Then plus or minus the square root of b, which is negative 5, squared, minus 4 times the a, which was 2, and times c, which was a 3. And then we're dividing that whole entire amount by 2 times the a, which was 2. So there it is plugged in. I would strongly suggest that you plug in the numbers before you just try to do too much up in your head. A lot of things can get lost at that point. So let's just start going through step by step. So first, let's take care of negative 5. That becomes a positive 5. We're going to leave the plus minus square root. Not going to do anything with that square root until everything underneath has been resolved and figured out. So negative 5 squared is 25. Minus 4 times 2 times 3 is really minus 24, because 4 times 2 is 8, times 3 is 24. And then we can do the denominator. 2 times 2 is 4. So we'll go one more step before we kind of break this apart. I have 5 plus or minus the square root of 1 over 4. Now, we want to make sure that this b squared minus 4ac is greater than or equal to 1, or I'm done. Well, we can see that we definitely do have a positive number underneath here, so I can keep going. This one happens to be perfect because it's a perfect square. So what I do with this is I'm going to have two breakouts at this point. I'm going to say 5, the square root of 1, remember, is a positive 1, or x equals 5 minus 1 over 4. So remember, the square root, we're taking the plus and minus of that square root. So 5 plus 1 over 4 means that we would get x is the same thing as 6/4, which I can reduce to 3/2. The other solution, 5 minus 1 is 4, divided by 4 is 1. So if I was to graph this, these would be my two x-intercepts. These are my solution, and these are also our roots. So example 1 also could have been solved with factoring. So if you had seen the factoring and wanted to follow through with that, you should get the same answer. We decided to use the quadratic formula, and we get the 3/2 and the 1. So now in example 2, looking at this function, this one definitely looks like one that I don't even want to think about trying to factor this. I wouldn't even want to think about trying to put together a completing the square or certainly graphing it. So here's where the quadratic formula, as much as it's a long formula, will actually help us here. So here we have the number, which is the y value of Northern Rocky Mountain wolf breeding pairs. So this is the number of pairs over X years since 1990. So when were there about 35 breeding pairs? So if I look at this problem, the first thing I got to think about is the breeding pairs is the y value. So what I first I'm going to do is I'm going to kind of just rewrite this with 35 in front. I won't rewrite all these decimals, but this would be the new equation. 35 equals 0.2 x squared plus 1.8 x minus 3. So to use my quadratic formula, what I have to do is get that 35 moved to the other side, so we set up the ax squared plus bx plus c equals 0. So by subtracting 35, I am going to get 0 equals 0.2x squared plus 1.8x minus 38 now on the other side. So we had to move everything over to then be able to use the formula. But now I have my A, 0.2, my B, 1.8, and my C, the 38. So let's just start plugging it in and seeing where it goes. So now x equals negative b, negative 1.8, plus or minus, and it's always plus or minus, square root of b squared minus 4, the a is 0.2, the c is negative 38. Now, if this 38, negative 38 was a positive, we would have had a whole different situation here. This is a negative that goes with that negative 4 in the front, so this is going to work out. And then underneath, we have 2 times a, which is the 0.2. So next line, we have negative 1.8, and now we have to go in and start taking care of our numbers. 1.8 squared is 3.24, which when I add 4 times 0.2 times 38, 30.4, and again it's all over now 0.4. So when I go to my next line, I have negative 1.8 plus or minus, and I have the square root of 33.64 all over 0.4. So then I go a little bit further. I can take the square root of 33.64. I get negative 1.8 plus or minus about 5.8 over 0.4. Here's where I have two solutions. The first one, I do negative 1.8 plus 5.8, divide by 0.4, and I'm going to get 10. The second one, I do negative 1.8 minus 5.8, divide by 0.4, and I get approximately negative 19. Now, since the answer here is looking for since 1990, so we're not going to really refer to the negatives, although you could argue it's 19 years back, it also happened. We're going to focus on since 1990, so going forward, how many years were until with this model there were 35 breeding pairs. So it will be 10 more years, or you could certainly put the year 2000. Okay? So now I want to talk about this b squared minus 4ac in this thing. We've talked about a couple of times about how at the beginning, how it has to be a positive number or 0. We've looked at it a couple of times about how it's really the first major thing you've got to work your way through before you can add in the other minus b and then divide. So what is this thing? This thing is called a discriminant. So the number underneath that expression, b squared minus 4ac, is called a discriminant. So because it is under the radical symbol, as we already talked about, it's going to help us to determine the number of solutions our quadratic will give us, which is also the number of x-intercepts. And here's how that works. So looking at this diagram here below, if I have a discriminant, if this whole expression, b squared minus 4ac, is greater than 0, that means that there are going to be 2 solutions or 2 x-intercepts. We saw that in both of these examples, 1 and 2. If that b squared minus 4ac is positive, there will always be 2 answers. However, if b squared minus 4ac equals 0, we know when we take the square root of 0, it would become 0. There is no plus and minus 0, it would just be plus 0. That would tell me that there's only going to be 1 solution. So we're not splitting off into those final 2 numbers that we're finding. And we haven't seen this yet, but if b squared minus 4ac is less than 0, we all said we can't take the square root of a negative, then that tells me that there are no intercepts and there are no solutions. So sometimes it's worth focus on the discriminant first. Plug your numbers in, but focus on that discriminant. If you see that there should be no solution, then just you're done. If you can see a 0, then that just tells you what your answer should be. So it's kind of a way to get a little bit of a head start as to what you should be getting as you go. Okay? So example 3. Determine the number of real solutions. So here's an example that maybe, before I start plugging in this crazy long formula, I focus on what is it that's really the most important right here. Before I do anything else, it's just saying determine the number of solutions. So if I just do discriminants, that'll tell me how many solutions I have. I do need to make sure that I'm in a squared plus b squared plus c squared equals 0, which this one is. So the b is 8, so 8 squared minus 4. The a is a 1 because there's nothing in front of the x squared, and the c is a minus 3. 64 is 8 squared. 4 and a 3 is 12, and I'm adding. So in reality, at this point, I don't really need to know this number, but I know that there are going to be 2 solutions because 76, which is the discriminant, is positive. So now that I have that, you might say, well, that's a lot of wasted work. Now I still have to go find the number, but I now have that expression already to start plugging in. Looking at the second one. So the second one, it's not in standard form yet. So it's important that you note that you can't make this determination until I have it in standard form. So to get it there, I need to bring that 6x over with subtraction, and then I can add 1 to get that 0 on the right-hand side. So now I have my a, my b, and my c. I'm going to focus on the b squared minus 4ac. The b is the negative 6 minus 4 times 9 times the c, which is a 1. Negative 6 squared is 36 minus 4 times 9 times 1 is 36. You get a 0, so there will be 1 solution. And again, it is not wasted time because with both of these examples, I already have part of the formula filled out, so it's not a waste. If these came out to be a negative, I definitely have saved some time because then I can just say no solution and don't even bother with the rest of it. So here we are in example 3. Again, we're asked to find the number of x-intercepts. So that just means figure out that discriminant. Focus on that first. So the discriminant, if I do b squared, the b is a 3, so I'm going to square that, minus 4, the a is a 2, and the c is a 9. So then I get 9 minus 72. Now, here's where we are going to get a negative answer. We're actually going to get, what, negative 63, is that right? But the point being, we get a negative answer. Once we have a negative answer, there is no solutions. So we will not get any real number solution. This will be one that the vertex would be above the x-intercept if it was opening up, or it's below the x-axis if it's opening down. It will not cross the x-axis if I was to make a graph. And so I just want to talk about this little chart. So we've talked about a bunch of different ways to solve these quadratics. Back in chapter 7, we talked about how we can factor things. We've talked about graphing. We've talked about solving with square roots, completing the squares, and now quadratic formula. So this chart just kind of tries to break it down a little bit as to what are the pluses and minuses for all these. So all of these methods can work to solving. Some of them will be better for certain situations. So for factoring, they're pretty straightforward when we can take an equation and factor it easily. So if you can right away see a quadratic that can be factored pretty easily, then I would suggest using the factoring method. Okay. The disadvantages is sometimes our equations, as we saw, are not factorable. So you can't just say, well, I'm going to try factoring, and if it's not factorable, there's no answer, because we can find an answer. We just can't use factoring. So if it's easily factored, go for it. If you can't factor it, then you have to try a different way to get to the next answer. Okay? Graphing. Graphing, you can easily see the number of solutions. We know the solutions are our x-intercepts, so we can always see those very, very easily. Okay? So use when approximate answers are sufficient. You don't always look at an x-intercept and say, oh, that's definitely 5, or that's definitely 5.5, or that's definitely 5.45. It's hard to know if you have to get a specific answer with graphing. And if you can use a graphing calculator, we didn't get a chance to spend much time with that this year, but a graphing calculator has buttons that you can push that it will tell you your very specific x-intercepts once you've made the graph, where we can't see it manually. Okay? The disadvantage is it may not give exact solutions. So as we just said, if you don't have a graphing calculator and it doesn't land perfectly on the x-intercepts, you're kind of guessing a little bit, so it doesn't always give exact answers. So using square roots. So you want to use this one every time you see that you have something like this, where you have that x squared minus equals d. There's nothing to do here. All you got to do is take the square root of both sides and you're done. So that was one that you want to isolate the x squared by itself, make sure that it only has one x term, either x squareds, or if you happen to have one that just has an x, that's even easier, that's a linear one basically. But the x squared by itself in one term with no other x term, using square roots is super easy and fast, doesn't take much effort, and it only can be used in certain equations, obviously, because if you have an x squared and a bx, you can't use it. Okay? Completing the square. So this one is best used when the a is a 1 and b is an even number. So remember, we isolate the x squared plus bx. We take half of the b. So it's going to be easier when we take half if it's an even number, and then we turn around and square it. If it's an odd number, you can still do it. You still can square fractions, but it's a little bit more challenging. But if it's a 1 for the a, it's an even b, that's one to consider. Obviously, it can sometimes come up with some difficult calculations, but again, you use a calculator. And then there's the quadratic formula. So the quadratic formula, the major advantage here is it can be used for any of our quadratic equations. It can be used for any single one we want. We just have to make sure we get into ax squared plus bx plus c equals 0, and it gives exact solutions. It's always going to give us the most exact of all of these. Okay, so the negative, the downside, it takes time. There's lots of calculations to follow, lots of order of operations to follow. It takes time to do one of these. It takes organization to do one of these well, not to make a mistake. All of them will get the answers. These are some of the advantages and disadvantages. So solve each by any method. So looking at this first example A. So to me, the A is a 1. The B is a even number. So I would choose completing the square. So remember completing the square. I would keep, let's get back to that. Hit the wrong thing. I need my stylus. So x squared minus 10x equals 1. Remember, for completing the square, I take half of the b, which is a negative 10. So half of b is a negative 5, and then I square it. Negative 5 squared is 25, which means I have to add 25 to both sides. Remember, that's the completing the square part. Now, x squared minus 10x plus 25 is one of our perfect square trinomials. It is x minus 5 squared. And on the other side, we get 26. So from here, this is where we take the square root of both sides. That's going to leave me x minus 5 on the left-hand side, and remember, plus or minus the square root of 26 on the right-hand side. So the square root of 26, I'm just going to round it. It's x minus 5. It's about plus or minus 5.09. I'm just going to round it to approximately 5. Then I would add 5 to both sides. So 5 plus 5 is 10. 5 minus 5 is 0. So my two solutions would be 10 and 0. For the next one, this might be one that you might spend some time trying to see with the factoring part. You do the 2 times a negative 24 to get negative 48. See if you can find the factor pair that gets you to the plus 13. You can certainly do that if you want. To me, this might be one that's not as easily factorable, so I'm going to maybe shift into that quadratic formula possibly. And by doing that, here's what I would do first. So I'm going to do x equals, I'm going to do this b squared. So negative 13 squared minus 4 times a times c. And I'm going to focus first on that. Because if that doesn't work out to be a positive number, then I don't need to go any further. So I'm going to kind of pause for a minute. So negative 13 squared is positive. The negative 4 times a positive 2 times a negative 24 will be positive. So yes, it will be positive. So then I can kind of think, all right, I got to go back and figure all this out. Negative b is that first thing, which is negative 13, which is going to turn into a positive 13. And I'm going to do 2 times a in the denominator, which is 2 times 2, which will be 4. So my next line is 13 plus or minus 361 when I put together my discriminant divided by 4. So that means I'm going to get 13 plus or minus 19 divided by 4. So again, my two answers will be 31, 32 fourths, which is 8, and 13 minus 19 is negative 6 fourths, which is negative 3 halves. So x equals 8 or negative 3/2. And on my last one, I see that the a is a 1. Looking at those numbers, 8s and 12s, I'm thinking this might be one that's factorable pretty simply. So if I look at this, I'm looking for the factor pairs of 12, a positive 12, that will give me a positive 8 when I add them. So looking at my factor pairs of 12, I have 1 and 12, I have 2 and 6, I have 3 and 4. Now we knew they both had to be positive because that b value is going to be positive in the middle, so if they are both negatives, that wouldn't have worked. We also know that both signs had to be the same to get that positive 12 at the end. So obviously 2 and 6 gives me that 8 in the middle. So this is where the double bubble plays in. I would do x plus 2, and I would do x plus 6, which then means with the zero product rule, I can break this apart and solve these two to find my answers. So x equals negative 2 or negative 6. And again, I could have used a quadratic formula if I wanted to. I could have probably gotten away with just using completing the square if I wanted to. But to me, this one was one that I was able to see that factoring easier. So lots of times it's going to come down to you. Which method is the one you happen to see the best, which one you want to go with, and which one you want to stick to. But this kind of wraps up all these solving quadratics. We've seen all these different ways with the chart. Really focus on your order of operations through this one with the quadratic formula. And if you have any questions, please feel free to let me know.